Hi folks, we're now going to be looking at the supply side of the economy. So we're going to be looking at firms' profit maximization problem. And a firm's profits, of course, is given by this. So a firm producing good G, its revenues is given by the price times the quantity that it sells. And you'll notice that it takes prices as given here. So we're assuming perfect competition in goods markets. Its costs, now I'm going to assume there are two factors here, labor and capital. So its costs are given by its labor costs less its capital costs. Now, a couple of things to note here. One, both wages and the return on capital do not have a G subscript. So you can imagine there are many different firms producing different goods, but labor and capital are perfectly fungible and they can move freely between different sectors. So every representative firm in each sector is going to be paying the same wage and the same return to the capital holders. The production function, so the quantity that the firm produces, is going to be given by this Cobb-Douglas production function. That looks like this. So let me substitute that in here. And now we can go ahead and take the first order conditions for the firm's problem. So firstly, with respect to capital, take the derivative of the profit function with respect to capital, set it equal to 0, and that will give me an optimality condition for capital demand. And that looks like this. Excuse me, it should be capital. So we should have an R here. That's equal to 0. Now, first things first, we can go ahead and rearrange this by taking the return on capital to the other side. So I'm going to go ahead and do that. And what we have here is that the return on capital is equal to the marginal revenue product of capital. So we also have perfect competition in factor markets here because firms take factor prices as given. Now we also have an optimality condition with respect to labor demand. And that gives us the following condition. Or in other words, that the marginal revenue product of labor is equal to the wage. Now we can go ahead and combine these two expressions by dividing one by the other, and that gives us the following ratio. And this, of course, tells us that the marginal rate of factor substitution, or sometimes called the marginal rate of technical substitution, is equal to the ratio of the factor prices. And this is one of our conditions for production efficiency. So note that, again, factor prices are the same across all firms. So we're going to have that the marginal rate of technical substitution is going to be the same across all firms. And that means there's production efficiency. We can't rearrange the inputs of the different firms in order to make all firms produce more. We can do some cancellation here. So obviously the price of the good does not factor in here. And we can simplify it a little more like this. And I'm actually going to write that as a relative demand function for capital. So capital demand is increasing in labor demand. It's decreasing in the relative price of capital, of course, and it's increasing in the capital intensity of the good, which is given by alpha, of course. So if a good is more capital intensive, or if the price of capital relative to labor is cheaper, then demand for capital is going to be relatively high compared to demand for labor. We can graph this. Looks like this. If we have labor demand on the x-axis and capital demand on the y, of course this is just going to be a linear function with the slope given by alpha over 1 minus alpha times W over R. So if alpha is larger, if the good is more capital intensive, or if the wage is relatively high, in other words, the cost of capital is relatively cheap, then this slope is going to be steeper. We can also rearrange the first order conditions to tell us a little something about the share of factor income. So if we take our first order condition for capital, for example, we can rewrite it as okay, and we can rearrange this to give this. And this tells us on the left-hand side, total capital income relative to total revenue is equal to alpha. So it's just going to be a constant factor share. And this is a unique result for the Cobb-Douglas production function, that factor shares are equal, just constant and equal to the factor intensities. We can derive a similar expression for the labor share, which of course is just equal to 1 minus alpha. Now we can also plug these expressions for capital and labor demand into the profit function. And because we have perfect competition in both goods and factor markets, we should expect to see zero profits. So let's see if we do. So remember, profits are given by revenue less wage costs and capital costs. And I'm just going to substitute in from these expressions for factor shares. Alpha times PQ for capital costs and 1 minus alpha PQ for labor costs. And clearly this is equal to 0. We can also substitute in to the expression for Q here, a slightly rearranged version of this. So if we rearrange this as K equals alpha over R times PQ, and the same for labor from here. And we substitute that in to Q here. So remember, Q from the production function is given by A K to the alpha times L to the 1 minus alpha. I'll write it out like that for now and just keep the alpha PQ minus 1 minus alpha PQ. And now we can substitute in these expressions for capital and labor demand into this production function. So we have alpha over R times PQ to the power of alpha. That's capital demand. And then labor, we have something similar. Now we can do a lot of cancellation here. We have a Q to the power of alpha times a Q to the power of 1 minus alpha, which is just equal to Q. And we have Q's here and here. And this whole thing, of course, is equal to 0. So we can cancel the Q's. We can divide by Q. We also have a P to the alpha and a P to the 1 minus alpha, and P's here, so we can cancel these here as well. And of course, this alpha minus 1 minus alpha, that just is equal to minus 1. And so rearranging slightly, we have PG times A, the alpha over R to the power of alpha times 1 minus alpha W over W to the power of 1 minus alpha minus 1, and I can just move the 1 to the right hand side and we get equal 1. And if I just rearrange again, I get that the price is equal to 1 over alpha times R over alpha to the power of alpha times W over 1 minus alpha to the power of 1 minus alpha. And this, of course, is equal to marginal cost. So we have the result that we expect under competitive markets, which is that price is equal to marginal cost. Thanks very much. I'll see you in the next video.